Kia ora koutou katoa, it's Mrs. Goodson here. This video is about factors that affect rate of reaction. So it's to do with acids and bases external assessment and also our internal assessment, which is a chemistry investigation. So we started talking about rate of reaction in our earlier video when we talked about particle theory and collision theory. So the rate of a chemical reaction is how fast the reactants react to form new products. So the slower a reaction, the longer it will take to happen, so the bigger the time. So rate is the inverse of time. Experiments can be carried out to measure how fast different reactions occur, and we're going to do some of those experiments in the lab, in the school lab. The rate of a chemical reaction can be increased by changing the reaction conditions, which will result in more effective collisions of reacting particles. So it also can be decreased by changing the reaction conditions, which will result in less effective collisions of reacting particles. So we're either trying to increase collisions or decrease collisions and thinking about what makes them effective. So these are the four factors that we're going to investigate that affect the rate of reaction: temperature, concentration, surface area, and catalyst. So these are the definitions of what we talk about when we talk about these four things. So temperature is how hot or cold a substance is. The hotter the temperature, the more kinetic energy the particles have. So if the particles have higher temperature, then they have more kinetic energy and they are moving faster. Now, concentration relates to the strength of a solution and the amount of a dissolved substance in a given volume of solvent. So if we could see the particles, if the particles are coloured, then we'll get this continuum from diluted to more concentrated. However, most of the solutions we deal with are colourless, so we can't actually see this gradient of more particles per unit volume. So surface area relates to solid substances, and it is the sum of all the faces as the surface area. So the surface area increases as the particle size decreases. And we can see this, we've got one big particle here, and we've got these surface areas, these surfaces, as well as the ones we can't see in this 3D picture. But if we divide up the big chunky chips of whatever into smaller parts, then there's actually more surface, a lot more surfaces exposed. And then if we ground it up into even smaller pieces, then we get these there are more particles exposed, and so because there's more surface area. A catalyst is a special substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. It doesn't get used up, it just affects the rate of the reaction. So let's look at each of these in turn. The first one is surface area. So this is a block of calcium carbonate, maybe a chip of limestone. If we break it into smaller pieces, you can see that where the arrows are, there are more surfaces for the particles to collide. So this might be acid particles, hydrogen ions, they're coming in. So if there are more surfaces to collide, then there are more collisions per second and the rate will increase. Concentration, as I said, you can't always see the differences in concentration, and we talk about moles per litre or molar. All right, so in chemistry, and this is going into level 2 chemistry, we talk about moles. We're talking about particles per unit volume. So if we increase the particles per unit volume, so these beakers all have the same amount of the solvent, the water, but there are more reactant particles dissolved. So we've got sodium ions and chloride ions. So this is salty water. This one would taste a lot more salty, though we wouldn't taste it in a lab, but we could taste it in a kitchen. There's a lot more particles dissolved in the water. Temperature relates to how fast the particles are moving. So if the particles are moving faster, then it's going to have more of this movement energy, more of this kinetic energy. So the particles are moving faster and they've got more energy. So that's going to affect the effectiveness of the collision and the collisions per second. Now, a catalyst provides an alternative reaction pathway. It doesn't get used up itself because it's not a reactant in the chemical reaction. It lowers the activation energy, and there are specific catalysts for specific reactions. Okay, so this is the energy diagram of what. So we've got energy up here and reaction profile. So we go from the reactants to the products. In this case, the reactants have more energy than the products, but we need to add a little bit of energy to get the chemical reaction started. And with a catalyst, this we need less energy because the collisions are more effective. All right, so when we're talking and explaining about rates of reaction, we need to talk about particles and then how that relates to collisions. So if we talk about temperature, then the particles are moving more quickly and they have more kinetic energy. So therefore, if we increase the temperature, there will be more collisions per second and they're more likely to be successful. Okay, so we need to mention particles, what happens to the particles, and then what happens to the collisions per second. Or we can talk about frequency of collisions, but we have to relate it to time because we're talking about rate. So therefore, in this case, the rate would increase. In concentration, there are more particles in the same volume. So the particles are closer together, and so there will be more collisions per second. You can also talk about particles per unit volume. Surface area means there are more particles exposed, and so therefore there will be more collisions per second. Now, the catalyst is a little bit different because it doesn't directly affect the particles, but it provides an alternative reaction pathway that lowers the activation energy, and so the collisions are more likely to be successful and the rate would increase. All right, so these are just, you have to make sure that you are explaining in the correct terminology about particles, collisions, and rate. And we want to link these together. So we use phrases like because, and so this means that, and so therefore. So in this video, we have defined the 4 factors: concentration, temperature, surface area, and catalysts that affect the rate of reaction and describe them in terms of particles. Now, these are 4 factors that we can change. We can use in our investigation. We just change one of them, and then that would form our independent variable, and we keep the other ones the same. So then they become the controlled variables. We just want to change one at a time when we're designing our investigation. And then we've talked about how we explain these changes of rate in terms of the effect on particles and collisions.